Alright, now let's talk about the radical function and doing transformations with it. And let's ultimately try to sketch the graph of y is equal to 3 times square root minus x minus 1. Okay, so there's a couple methods you could use to do this. Personally, what I usually do and what I teach students is to first just graph the radical function. So if we kind of make a little table of values for square root of x, if you have square root of 1, you get 1. And remember that inside of the square root always has to be greater than or equal to 0 because you cannot square root a negative number. And the easy points are like 1, 1, 4, 2, because square root of 4 is 2, square root of 9 is 3, and 16 is 4. So if you were to kind of plot this, and also of course 0, 0, you can do kind of like this and get the original graph. 4, 5, 9. So that is the graph of square root of x. So now let's apply the transformations. So let's take our points and let's multiply them by 3, and we'll get the transformed graph. So 1, 1 will become 1, 3. 0, 0 stays the same. 2, 4 will become multiplied by 3, so it'll be kind of up there and become 12. So 1, 2, 3, 4, 5, 6, 7. So it will basically be out of the graph. So just kind of approximate it. And then the next step we can do is do the reflection. So that is going to mean that all of our x values switch. So 0, 0 will stay the same, but 1, 3 will now become negative 1, 3. So this is going to be like this, negative 1, 3 for the dealing with the negative. So then, and then, yeah, so those are the only points that we're basically doing. So just kind of connect them. And then we're going to take the graph and move it 1 unit to the right. So to graph that, I'm just going to take the blue points and then just move them over. And that's because we're dealing with the x minus 1. So basically, you can also just put the points into the like function and kind of make a table of values. So that's for like f of x. So like the y equals 3 square root minus x minus 1. And if you put in like 1, your new point will be, or like if you put in something like say 0, you will get like minus x minus 1, so 0 minus 1, and then multiplied by 1, so square root of 1. So it'd be like 0, one sec. So if you put in 0 into the function, you should get 3. And then if we put in the other values, we can fill out the table of values as well. If you put in like 1, you'll get 0, and so on, to get a sketch of the graph that way. The domain for this will be negative infinity all the way to 1, and the range will be from 0 to infinity. Oops. And you can get more points if you just put them into the function. But yeah, that's going to be our final function. Let's try doing this one. So for this one, we can basically graph the original first. So So the way this one would work is like if you put in some, just put in some points. So like 0, 0 becomes 0, 3, 1, 1 would ultimately become 1/2, 2, and 8, 2. So like the original function would look like 0, 0, 1, 1, -1, -1, and that's just like the graph of third root of x. So just putting in some values and then just like doing that. -8, 2. So 1, 2, 3, 4, 5, 6, 7, 8. And then +8, 2. 1, 2, 3, 4, 5, 6, 7, 8, 2. And then basically just kind of look like this for the function. And then that's before doing the transformations. And then from there, it's a horizontal compression of 2x. So all the points will be moved inward. So that if this was 8, 8, 2 would then become 4, 2. 3, 4. And then this one would be at -4. 2, 3, 4. So our new graph would be kind of like this. And then from there, you can do the reflection. So this tells us reflection over the axes, the x-axes. So it's going to become like this. So that 1. And then flip over. And then 4, 2. And then lastly, everything would be, so if we solve for y, it would be equal to -3 2x plus 3. So just move all the points up 3. 1, 2, 3. 1, 2, 3. This one will be here. 1, 2, 3. 1, 2, 3. And then the function would just look like this. Just something like that, and smooth it out. Okay, so that's personally the way I would do it. I just take some points and then kind of do the transformations to see where they would like end up, and just go step by step. And if you haven't seen the videos on transformations, that would be a good thing to do before watching this one. So the domain and range would be x belongs to all real numbers. The range would be y, such that y belongs to all real numbers. Okay. Now, let's try this. So the point 36, 6 lies on the graph of square root of x. What are the coordinates of the image on -1/2 root 3x? Okay, so the first thing that's going to happen in this function is a vertical stretch by 1/2. So if we started with 36, 6, vertical stretch of 1/2 would mean that it would become now 36, 3. And then it's negative, so we reflect over x. And that would make it 36, -3. Horizontal stretch by 1/3, because the b term is 3, and that's always like 1 over the b term. So we would get a horizontal compression in the x, so that's going to be 12, -3. And that's our final answer. Okay, now let's write some equations. So if we take y is equal to the third root of x, and then we apply these transformations, so vertical stretch by a factor of 3, reflection in the x-axis, translation right and down. So that's going to be the 3 would be equal to y is equal to 3 third root x. Reflection would mean it's going to be negative, so y is equal to negative 3 third root x, and then right and then down. So right would mean x minus 4, and then down would just be like minus 2. So now we just put it all together. So it would become y is equal to negative 3 third root x minus 4, and then minus 2. And then this ends like right here. The minus 2 is outside. Okay, let's try the next one. Horizontal stretch by a factor of a half, reflection in the y, vertical stretch by 3, and then translation of 6 units left. So first thing, horizontal stretch by a factor of 1/2 would mean that it's equal to y is equal to third root 2x, because it's always like the opposite, because it's always like 1 over b. So if we want a stretch of 1/2, the b would be equal to 1/2, and then that's going to just be 2. And then it's a reflection in the y-axis, so that's going to make it negative 2, negative 2x, and then vertical stretch by a factor of 3, so we can put a 3 out there. And then reflection in the x as well, so let's make it negative. And then translation of 6 units left would mean it's x plus 6. So putting it all together, I'm just going to make another page. We would have y is equal to negative 3 third root negative 2 in brackets x plus 6, and then end there.